Good day. So in this video, we are going to discuss the sequences and series. So before we do that, I just want to take this opportunity to appreciate all those who have subscribed to my channel. And if you are new to this channel, please go ahead and hit that subscribe button and share the video with colleagues and friends. Now, getting back to today's business. So I just want to summarize the sequencing series here from grade 10, 11, and 12, and we are going to try and do this thing under 30 minutes. Now, let's get into it. Now, what you need to know about the sequencing series, there are three kinds of sequences that you need to be familiar with at grade 12. Firstly, that is the arithmetic sequence, and the second one is the quadratic sequence, and the third one is the geometric sequence. So we are going to discuss these sequences in detail and separately. So we'll start off with the arithmetic sequence. Now, the arithmetic sequence is also called the linear pattern. This is a sequence that has got a general equation Tn is equal to a plus n minus 1 d. You need to familiarize yourself with these general equations of the arithmetic or the geometric or the quadratic sequence. Where a, to define a, that will be the first term of this sequence. So that is the first term of the sequence, and d is called the common first difference. So this is a feature about a unique feature about the arithmetic sequence. It has got the first common difference. So for example, if you have got the sequence 3, 5, 7, and 9. So the common difference here will be always the succeeding term minus the previous term. For instance, that will be 9 minus 7. So that will give us a 2. And you can see here again, that's a 2. And here again, that's a 2. So there is a first common difference. So the common difference of 2, that is this common difference that we talked about here. Now, that is the unique feature about the arithmetic sequence, the first common difference. Remember that. Then the other thing that you need to familiarize yourself with is that if you take the Tn formula and just substitute 1 there, what you are determining is the first term, and that will be equal to a. And if you put a 1 on the end, that will be 1 minus 1, then times d. So you can see that T1 is a. Then you can actually go ahead and also determine T2, and you just substitute again the value of n for 2, and then you get here a plus d, because 2 minus 1, that will give us a 1 times a d, then it's a d. Then T3 will be equal to a plus, then here a 2d. And T4 will be equal to a plus 3d. So, and so on until you get to Tn, which will just be that formula there. Now, with that in mind, the other thing that you can also be asked to determine for an arithmetic sequence is the sum of the arithmetic sequence. So if you have got if you are given the arithmetic sequence and they say calculate the sum of the first 8 terms or 10 terms or 100 terms, you just use the formula sum of the n terms is equal to n over 2 bracket 2 times the first term plus n minus 1 then times a d, where the a is, again, remember, the first term, and n is the number of terms. So n is the number of terms, and d is the common difference. So if you have that number of terms, you just plug in the unknowns, which is the n and the a and the d, and then you calculate the s of the sum of the first 100 terms or whatever terms that you'll be asked. So that is quite easy. Just punch into that formula. Now, if you are given also the last term, you can use the formula Sn is equal to n over 2 bracket first plus last term. So if this formula works by, if you have got the last term, so if they give you a sequence, they say, oh, the last term is that. So if you know what the last term is, then you can just use this formula. Or even if you use that or this formula, you still get the same answer. Now, with that in mind, let's look at an example of the arithmetic sequence. Now, in this example, we are told that the first term of arithmetic sequence, so it is always good to underline here. So you know that you're dealing with an arithmetic sequence, is -1. So a is equal to -1. And we are also told that the seventh term, so remember T 7 can be calculated as equal to a plus n minus 1 d. You can actually, okay, let's say the Tn here. Remember the Tn of the arithmetic sequence is equal to a plus n minus 1 d. So the T7 can be equal to a, in this case it's negative 1, plus n, which is 7, minus 1, so that will be 6d. And in this case, we are asked to determine the common difference of the sequence. So we are just asked to determine d, and we are told what the seventh term is, and we are told that the seventh term is 35. So we just say 35 is equal to negative 1 plus 6d. And to simplify that, you see that will be 36 is equal to 6d, and d is equal to 6. And that is how you do the common difference. So the common difference here will be a value of 6. Now, the next part of the question, we are asked to determine the number of terms if the last term is 473. Remember, now we are still dealing with the Tn. So remember, Tn is equal to a plus n minus 1d. Always write down your formula. So in this case, we are told that the number of terms if the last term is 473. So the Tn is 473. That is the last term. So 473 is equal to, remember our first term, it's negative 1. So negative 1 plus, in this case, we don't know n because that's what we are calculating. We are determining the number of terms. So n minus 1, then bracket times 6. And that will give us 473 is equal to negative 1 plus 6n minus 6, which can be further simplified to 480 is equal to 6n. And if you divide by 6, then you can see that your number of terms will be equal to 80. And that is how you determine the number of terms for the second part. Now, for the last part, we are asked to determine the sum of the first 40 terms. Remember, we said the moment they are talking about the sum of the arithmetic, you remember your formula, so we don't know the last term here. So we'll say Sn is equal to n over 2 bracket 2a plus n minus 1 bracket times d. So in this case, we want to find S40. So S40 will be equal to 40 divided by 2, then in a bracket 2 times negative 1 for our a, plus we know how many terms we want to determine. That will be 40. So 40 minus 1, that will be 39d. And if you punch this in your calculator, you realize that the sum of the first 40 terms will be equal to 4,640. And that is how you determine the sum of the arithmetic sequence. Let me know if you have any questions on the arithmetic. So just to summarize, remember the common feature on the arithmetic sequence, it is that it is the first common difference. And if you are asked to determine the sum, you just use the formula n over 2 bracket 2a plus n minus 1d. And also if you have last term, remember it's n over 2 bracket first term plus the last term, then you can also determine that. So let me know if you have any questions. Now moving on to the next sequence, which is the quadratic sequence. Now, the quadratic sequence. What is the quadratic sequence? The quadratic sequence does not differ in any way to the quadratic equations that you have been doing. So it's still quadratic, but the unique feature about the quadratic sequence is that it is the second common difference. So I would say just common difference. Remember, the arithmetic had the first common difference. So for the quadratic sequence, it has the second common difference. And also the quadratic sequence has got a general formula. Tn is equal to an squared plus bn plus ac. Remember what I said, it doesn't differ in any way to those quadratic equations, which are ax squared plus bx plus c. In this case, we are using n because it is the term number. So once we have that general equation, and you need to know this general equation. So once we have that general equation, we can actually determine T1 by substituting n for 1, and we get a1 squared is just 1, then plus 1 times b, that's b, then plus a c. We can also determine the second term, the T2, which will be equal to, in this case, we substitute 2 for n, that will be a 2 squared, that will be 4a, then plus 2b, then plus a c. And we can also determine the term number 3. So T3 in this case will be equal to 3 squared, that's 9a plus 3b plus a c. And you can go on and on and on and on and on. Now, once we have these 3, which is the T1, the T2, and the T3, remember we said that there is a second common difference. So what happens if we find the first common difference? So we want to find the first common difference between this term and that term, and also this term and that term. So remember, to do the common difference, you always say the succeeding term minus the previous term, the succeeding term minus the previous term, not the other way around. Otherwise, you get a negative. So here on the first one, so we have got 4a minus a, that will be 3a, then 2b minus b, that will be plus a b, then a c minus a c will just be a 0. Then on here, you've got 5a, which is 9a minus 4a, that will be 5a, then plus 3b minus 2b, that will be a b, then c minus c, it's a 0. So then we want to find, let's find the second common, the second difference. So that will be 5a here minus 3a, and that will give us 2a. And b minus b, it's just a 0. So if you can see, I'm sure you're quite familiar with these formulas. So this is the how you calculate your first term. So you use a plus b plus c, and how you determine the first difference. So the first difference will be determined by 3a plus b, and also the second common difference is determined by the formula of TA. So if you have got the second common difference of the sequence, and you have got the first common difference as well, and you have got the first term, you can be able to calculate the values of a, b, and c using this a plus b plus c, and 3a plus b, and also 2a. So I'm going to explain this in detail when we do an example in the next section. Now, in this example, we are given 75, 53, 35, 21, and we are told that this is a quadratic pattern. We're told that this is a quadratic pattern. So the first question is saying, write down the fifth term of the pattern. So we just rewrite our pattern and study the pattern. So that would be here 35 and also 21, and we don't know the next term. So if we minus this and that, we'll get negative 22. And if we minus 35 from 53, then we get negative 18, and 21 from 35. Then we get also here negative 14. And we can also, so you can see the pattern here, it's decreasing. It's actually increasing by 4. So 22 to negative 18, that's plus a 4. Then plus a 4. Then here you can see, then we can say the next term here will be minus 10. So we can say now 21 minus 10, and you can see that the fifth term will be equal to, so T5 will be equal to 11. And that is how you determine the T5 of this pattern here. So T5 is 11. Now, in the next bullet, we are asked to determine the nth term of the pattern. So let's just rewrite our pattern. So we just want to create some space here. So if let's just rewrite 75, 53, 35, and 21. And remember, the other one was 11. So remember, we said here the first difference was negative 22. And here it was negative 18. And here it was negative 14. So then if we find the second difference, we can see that the second difference will be 4, and that will be negative 18 minus 22, that will be positive 4, and also negative 14 minus 18, and so that will be positive 4. So if you remember from the previous section, we said that 2a is equal to the second common difference, and also we said here 3a plus b is equal to the first difference, and also we say that a plus b plus c is equal to the first term. So with this thing, you work it from down upwards, because on the top, you've got a lot of unknowns. So you have to find your A first. So 2A is equal to 4, then A is equal to 2. Once we get our A as 2, we substitute into the next one, which in this case is 3 times A. It's a 3 times 2, then plus B should give us negative 22. That should give us negative 22. And you can see that will be 6 plus B is equal to negative 22. And B will be equal to negative 22, negative 6. And that will be negative 28. Now we have got our A and B. Let's just write them down here. So A is equal to 2 and B is equal to negative 28. And let's just create some space to determine the value of C. And in this case, we use A plus B plus C should be equal to 75. And we know our A is 2, then plus, so it's minus 28. Then plus a C is equal to 75. And we say that C is equal to 75. So that will be 2 minus 28, here it's negative 26. Then that will be plus 26 this side. And you can see that C is equal to 101. So C is equal to 101. And let's just create some space here. So now we have got all the A, B, and C. Then we just substitute them into the general formula. Remember, the general formula for the nth term Tn is equal to an squared plus bn plus a c. So in this case, our A it's 2, so that will be 2n squared minus 28n, then plus 101. And there we go. We have our nth term formula. So that is the nth term formula for this quadratic pattern. Now, moving on to bullet number 3. In this bullet, we are asked to determine the minimum value of the number pattern. So that is the minimum value of the number pattern. So we're actually going to use this formula. So the minimum value, if you remember very well, so we have got here, this is a quadratic sequence or a quadratic equation. So to determine the minimum value, you have to determine the x-coordinate of the turning point. And if you remember, the x-coordinate of the turning point of a quadratic sequence is x is equal to minus b over 2a. So in this case, you just say your x-coordinate, that is minus b, so it's a minus 28 divided by 2 times 2. So that will be equal to, so in this case, that will be a 7. So that is the x-coordinate. But however, this is not the minimum value. So this is the x-coordinate of the turning point. So to get the minimum value, you now take that value of 7. So this is how you do the minimum value or the maximum value. So the maximum value, remember, you have an a of a negative, but in this case, a is positive. So it makes sense to determine the minimum value. So to determine the minimum value, now we put back the value of 7 into the sequence. So that will be equal to 2 bracket 7 squared minus 28 times 7, then plus 101. And if you punch that in your calculator, you'll get a value of 3. So this is the minimum value of the sequence. And let me know what you think. And this is how you do all your quadratic sequence. And these are the major things that you need to know about quadratic sequence. So in the next section, we are going to discuss the geometric sequence. Now, moving on with the geometric sequence. So remember, we're just also discussing the general formula. So for the geometric sequence has got a general formula. Tn is equal to ar to the power n minus 1. Where in this case, your a is equal to the first term. So that is the first term of the sequence. And r is the common ratio. So remember, in the arithmetic, we had a common difference, the first common difference, and in the quadratic, we had the common second difference, and whereas in the geometric, we have got a common ratio, and where n is just also the term number. So if you're asked to calculate term number 1, so you just substitute 1 into the n, then you can get your T1. So for instance, if we substitute now 1 there on the n, we'll get a to the power r 1 minus 1. So in this case, that will be 1 minus 1, it's a 0. So you know that any number raised to power 0, that will be a 1. So it's just A. Then your T2 will be equal to, so if you punch in 2 there, that will be AR to the power 2 minus 1. In this case, that will be AR only. So the 2 minus 1 is just A. So you can also determine the third term, and term 3 is equal to, that will be AR squared. Then term number 4, that will be AR cubed, and so on and so forth until the nth term. So this is your general formula for the nth term of the geometric sequence. Now, the other thing that you can be asked to determine is the sum of the geometric terms. So the sum of the geometric terms can be calculated as Sn is equal to, so if you have got the first term, you always have the first term, and then, or sometimes if you're not given the first term, you can calculate it using the Tn formula. If they say that maybe the second term is equal to 2. Remember, now you just say AR is equal to 2, and they say the third term is equal to 3. That will be AR squared is equal to 3. Then you just solve those equations simultaneously, then you can get your first term. So coming back to the sum of the n terms of the geometric. So the sum of the n terms will be the first term, then here bracket 1 minus the common ratio to the power n. This is the number of terms that you are asked to determine its sum. So maybe they can say the first 20 terms. So that is the number of terms. Then divided by 1 minus r. It really doesn't matter what formula you use. I've seen some students, they say, then if r is what, you can use this formula. It doesn't matter because if then it gives you a negative, it will give you also a negative at the bottom, and they can cancel out. So it doesn't matter which formula you use. Then the other thing that you can be asked to determine is the sum of the infinite terms. So that will be equal to a first term divided by 1 minus your common ratio. Now, so there are other sequences in geometric which can go to infinite. So let's suppose the common ratio is a half. Then you can see that that kind of a sequence continues on and on and on and on and on forever. So the number will just be becoming smaller and smaller and smaller, but not reaching 0. Now, the other thing is that you need to know is about converging sequence. So the converging sequence. So the geometric sequence can be called a converging sequence once r is greater than -1. So the values of r, they have to range between -1 and 1. So this kind of a sequence will be called a converging sequence. So if you just think of a moment. So let's say think of a number that is between -1 and 1, for instance, a half. So if we start with a number of, so let's 40, the next term will be halved. So the next term will be 20, and the next term will be a 10. So you can see now the number will continue decreasing and decreasing. So that will be converging. That is what is called the converging sequence. So yeah, we are going to do an example now to illustrate all this that we have been doing in here. Now moving on to an example. Now in this example, we are told that consider the following geometric sequence. So it's a geometric sequence. That the numbers 1024, 256, and 64. So to see that it's a geometric sequence, remember we said we have got a common ratio. So it's always the succeeding term. So that will be 256 divided by 1024. That will give us, so 256, that will be a quarter. So you can see again here, if you say 64, this term here, divided by 256, and that will also give you a quarter. So you can see exactly that this is a geometric sequence because we have got a common ratio of a quarter, and we're going to use that common ratio soon. Now, the first term of this sequence, we can see that it's a 1024, and the second term 256 and 64, and so on. Now we are told to calculate the 10th term of this sequence. Remember, now we are dealing with the nth term. So that is the 10th term. So remember, we say that the general term, the general formula for the term is equal to a to the power ar to the power of n minus 1. So in this case, we have got the a, which is equal to 1024. And we have determined r. If you remember previously, that was a quarter. So for the T10, so n will be 10. So that will be 10 minus 1. So if you just punch that in a calculator, you will realize that the term number 10 is equal to 1 divided by 256. And that is how you determine the 10th term. So every time they ask you determine the 10th term, this nth term, so you always have to use your Tn formula. Now, in the next part, we are asked to determine the sum of the terms from P is equal to 0 of the formula 256 bracket 4 to the power 1 minus P. So if you are given such a sum, the first thing that you need to do is always to determine the at least first 3 terms. Then that can give you an idea of what kind of a sequence it is. So if we substitute here, because we are starting at P is equal to 0. So this is just the formula. So we are starting from 0 to 8. So if we put a 0 there, we are going to have 256 bracket 4 to the power. So that is just 4. Was 1 minus 0, that will be 4. So this gives us 1024. Then if we substitute it, so now we are on number 2. So if we substitute a 2, you realize we're going to get 256 bracket 4 to the power of 1 minus a 2. And if you simplify that in your calculator, you realize that will be a value of 256. Because that will be like 4 to the power, so that is 4 to the power negative. So that is, so if, no, you substitute 1. So 1 minus 1. So the second term, because we started at 0. So if we start from 0, then the next term is 1. So if we substitute 1, that will be 1 minus 1. Then that will be a 0. So we get 256. Then the next term after this, we substitute a 2. So that will be here 4 to the power 1 minus a 2. And you realize that will be a 64. So you can see exactly that is the same sequence like that one. So this is actually a geometric sequence with a common ratio of a quarter again, because it's exactly the same with that sequence right there. So now we can actually determine the sum of the geometric sequence using Sn is equal to a of a bracket 1 minus r to the power n divided by 1 minus r. So that will be S sum of here. How many terms are there? So you see now we are starting from 0 to 8. So to be safe, every time when you're using summations, you always say this upper limit, and the upper limit is 8 minus the lower limit plus a 1. So if, for instance, if you're given, so always like m here, and starting maybe at r is equal to n. So to get how many terms or the number of terms it is, you always say m minus n plus a 1. Always m minus n plus a 1. So in this case, our m is 8 and our n is 0. So that will be 8 minus 0 plus a 1. So that means that we have got 9 terms. And even if you want to use your fingers, you can see that you have got 0 to 8, that is 9 terms. But now it becomes difficult if you have got big numbers, maybe starting from 35 to 101. So it's always good to use this formula, m minus n plus a 1. So once we know the number of terms, so the number of terms is 9. So S9 will be equal to A. That will be 10, 24, bracket 1 minus R. The R, remember, it's a quarter. Again, N, it's 9. Then divided by 1 minus a quarter. And if you punch that number in your calculator, you will get 1,365.33. And that is how you determine the sum of n terms of this kind of a sequence. So let's suppose now you had been asked also to determine the sum to infinity. So remember, we say that the sum to infinity, so if you're asked to determine the sum to infinity of this term, that will be sum to infinite will be equal to a divided by 1 minus r. So in this case, that will be a. In this case, our a is 1024 divided by 1 minus r, it's a quarter. Then you can punch that in your calculator. And you also see that the answer will be 1,365.33. And that will be the sum to infinity. And this is how you do the geometric sequence. And let me know if you've got any questions. And this brings us to the end of this lesson. Hope to see you again in the next video. Bye.